Have you ever typed something into Google, asked Alexa to play a song, or chatted with a chatbot about your order and wondered how on earth these machines understand what you mean? Well, the secret lies in the powerful branch of AI called NLP or Natural Language Processing. In this video, we will explore what NLP is, how it works, the challenges it faces, and how it's shaping the future of human computer interaction. Natural language processing or NLP is the field of AI that enables computers to understand, interpret, and even generate human language. Think of it as a translator between us humans who use complex, emotional, and often confusing language and computers which speak only in binary logical code. NLP combines linguistics, computer science, and machine learning to help machines process language in a way that's useful. Whether it's through text or speech, NLP allows computers to take our words and turn them into actions or responses. Asking Siri to remind me to call mom at 6, Google translating hello, how are you into French, a chatbot answering your question about your bank balance. Here's the thing, human language is messy. It's full of idioms, emotions, sarcasm, and sometimes complete randomness. Words change meaning based on context. For example, I saw her duck. Is that a bird or is it she bending down to avoid something? Machines have trouble with syntax, the rules of sentence structure, semantics, the meaning behind the words, context, understanding intent based on history or tone, and ambiguity, same word with multiple meanings. We humans process all this automatically. But for a computer, understanding the difference between that's cool, as in cold, versus that's cool, as in awesome, requires advanced modeling. With the complexity of language, NLP uses a bunch of pre processing techniques to clean and structure raw data. Let's break a few down. Number one, text normalization. Making text uniform so it's easier to analyze. This includes lowercasing all text, removing punctuation, removing stop words like is, the, and etc. Number two, tokenization. Breaking sentences into words or phrases. For example, I love NLP. It is defined as I, a separate word, love, another separate word, and NLP, another separate word or token. Third, we have stemming, reducing words to their root form. Running, runs, runner, all move to run. Lastly, we have lemmatization, a smarter version of stemming using vocabulary and grammar to find the dictionary base form of words. Was will be, better would be good. These steps help prepare the text for analysis by machine learning algorithms. NLP powers a wide range of applications that we use every day, often without even realizing it. For example, sentiment analysis, used by businesses to monitor brand reputation or public opinion from social media posts and reviews. It detects emotion if the feedback is positive, negative, or neutral. Then, text summarization. It automatically condenses large articles into short, meaningful summaries, great for news apps or academic research. Then there is a text classification, categorizing emails into spam, promotions, social, etc., using Gmail, document tagging, and support ticket sorting. Then we have name entity recognition. It detects names of people, places, organizations in text, useful in news and financial documents. Virtual assistants like Siri, Google Assistant, and Alexa rely heavily on NLP. They recognize your voice, convert it into text, interpret the intent, and respond accordingly. Chatbots are another classic examples. Some are rule based, they respond using a fixed set of scripts, whereas the others are AI powered. They learn from conversations, use natural language understanding, and even predict what you are going to ask next. These bots are widely used in customer support, online shopping, healthcare, and edtech platforms. But how do machines turn text into numbers so they can actually work with it? They use feature extraction methods like bag of words. It simply counts how many times each word appears in the document, easy to understand, but it ignores context. Then we have TF-IDF, that is term frequency, inverse document frequency. It's smarter. It gives high importance to rare but meaningful words in the document. Words like machine, learning might be more important than words like is or the. These numerical representations are then fed into machine learning models to perform tasks like classification, clustering, and prediction. Despite advantages, NLP still has many challenges. For example, sarcasm and humor. That's hard to detect. Then it could be multilingual understanding. Processing code mixed languages like English is still tricky. Bias and fairness. Models trained on biased data can produce discriminatory results. And then we have real time understanding issue. Speed versus accuracy is always a trade off. But the future is bright. With transformer models like BERT and GPT, NLP is evolving rapidly, enabling chatbots to write essays, code, and even generate poetry. NLP is one of the most exciting areas in AI today. It's what makes machines understand us, not just hear us. From simplifying tasks to automating insights, it's reshaping the way we live, work, and communicate. And as NLP keeps improving, we are heading toward a world where talking to machines feels just like talking to a friend. If you enjoyed this video, give it a thumbs up. Comment below what's your favorite NLP powered tool or application. And don't forget to subscribe to our Hashla coding classes.